Hello, and welcome to our review podcast on our particles unit. There are 4 objectives, nope, I lied, there are 5, that we will go through one at a time, and hopefully by the time we're done, you will feel prepared for our test that's coming. Objective number 1 is to explain and show diffusion, basically, for gas and liquids, and we want to make sure that we understand that particles are always moving. So first, let's take a look at what is diffusion. Basically, it's when we have a high concentration of something that will spread out evenly until it fills the entire container in the same amount. So rather than having perfume in one spot that's very concentrated, that perfume will spread throughout the whole room so that you could have perfume particles everywhere. Or when we drop a drop of food coloring in a glass of water, rather than the food coloring staying together, they will diffuse or spread out so that the entire liquid is colored with whatever color the food coloring was. So let's look at some evidence that particles are in constant motion. If you've ever looked at a sunbeam and seen the dust motes as they're moving and going all kinds of different directions, that's one way you can physically see that particles are moving. We know, for example, because perfume or smells will spread without wind or movement or blowing. A lot of people have done experiments to show that the particles are moving, or, when we did our lab with the balloon and the extract, you were supposed to guess what kind of extract it was, maple, by the way, and then tell me, how did the smell get out of the balloon? That is because the particles inside the balloon are constantly moving, and they're actually going through the balloon membrane so that your nose can pick them up. Objective number 2 is a review from one of our previous units. Basically, I want you to be able to show that if we change the amount of energy, it will change the amount of phase. Some things to remember: that our particles move, whether it's a solid or a liquid or a gas, that air does have mass, go back and watch that video if you wanted to see some evidence for that, and that each of the particles will have some distinct characteristics. So particles of a solid, close together, low energy, don't move much; liquid, medium speed, medium spacing, medium energy; and gas, far spacing, high energy, high speed. So how do you change from one phase to another? We either add heat or we take away heat. Just some things to remember about our review objective. Objective number 3 gets at the relationship between volume and temperature and motion. Basically, as you increase the motion of the particles, you will increase the volume. And the reverse is true. If I increase the volume, I'm increasing the motion of the particles. For temperature and motion, if you increase the motion of the particles, the temperature will increase, and then vice versa. If I'm trying to increase the temperature, I increase the motion. Now please keep in mind, water is an exception. If I decrease the temperature of water and freeze it, it will actually expand in the freezer. Everything else that we've encountered will decrease in volume if I decrease the temperature, with the exception of water. Now keep in mind, if it's a water-based product like soda or juice, it acts the same way as water. But in general, the rule is if I increase the temperature, I increase the volume, or if I increase the motion, I'm increasing the temperature. Objective number 4 has to do with buildings, how to explain why we need or how we need to take into account the changes of weather. In the hotter months when things will expand, or in the colder months when things will shrink, if a building or a sidewalk or a bridge or some man-made structure is not constructed in a way to be able to handle those fluctuations, then it's not solid, or it will crack, or it will have issues. So in general, things that, like metal, will expand with heat or contract with cold, need to have ways to adjust. Some of our favorites: buildings, sidewalks, bridges. Pretty basic. Objective number 5 is to show how density and particle size determine how materials settle and move. Now in the real world, there's a lot of overlap and a lot of mixing. Some things are very easy to determine, and others it's a combination. So let's look first at density. In general, more dense at the bottom, less dense at the top. Here's a picture of the soil lab that may help you remember. The other way is by size, that the largers go at the bottom and the smaller go at the top. Now we learned a song to help us remember the order of these particle sizes. They don't have to use these same names, but I hope the song helps. Here it is. Boulder, cobble, pebble, sand, pebble, sand, pebble, sand, boulder, cobble, pebble, sand, silt, and clay. So once again, in the real world, they're a combination. It's not so simple. Think about streams and lakes and rivers. Sometimes it's by density, sometimes it's by size, other times it's by natural phenomenon like glacier movement or flooding that will cause changes in things. So in general, the two rules we want to focus on now is sorting by density and sorting by size, and we will leave some of the more complicated things a little later as we get more into the real world. Well, that's it. Those are your 5 objectives for our particles unit. I hope this helped, and I will look forward to seeing how you do on our test that's coming up.